Let's take a look at this example. This time we're supposed to find the reactive power, QL. In order to do so, we're supposed to find X of L or BL. Let's take a look what we have given. We have given resistance, we have given total impedance, right? So what I'm going to do first, because I'm dealing with the parallel circuit, I'm going to find Y total, and I have Y total is equal 1 over Z total, which is equal 1 divided by 1.3 kilo ohms. Please notice that Z total, right, the value of Z total is not complete because we are missing angle. But angle we are going to find later on. So if 1 over Z total is equal 769.23 microsiemens. Next, I'm supposed to find G, conductance, 1 over R, which is equal 1 divided by resistance, 2 kilo ohms, gives me 500 microsiemens. Now, because our Y total doesn't have angle, I'm supposed to use Pythagorean theorem to find BL. The Pythagorean theorem says Y total square is equal G square plus BL square. In order to visualize this formula, you're supposed to remember that we are talking about the admittance diagram, not impedance diagram. We are talking about admittance diagram, where we have conductance. For example, this is G, this is your inductive susceptance BL, and we have total admittance YT. Please notice that the opposite side of my triangle has exactly the same length like BL. So this is my BL, okay, and this is my angle theta. So because we are dealing with the right triangle, right, we can use the Pythagorean theorem to find the missing side of the right triangle. In this case, we can find missing BL. So BL is equal square root, and I have Y total square minus G square. Plug in the values and you have square root, open parenthesis, Y total 769.23 microsiemens raised to the second power minus G, which is equal 500 microsiemens to the second power, and this is equal 584.56 microsiemens. Okay, so this is the inductive susceptance. Next, we're supposed to realize that next to Y total, we still don't have angle. We have to find the angle. So in order to find the angle, we're supposed to use the formula for power factor, because this is like a formula which you're supposed to use very often with this kind of circuits. This is equal cosine of angle theta, right? Where theta is my angle over here, can be found by simply finding the inverse cosine, right? And this is nothing else, just what? G, the adjacent over hypotenuse, yt. Okay, so theta is equal inverse cosine of G over yt. So I have inverse cosine G, which is equal 500 microsiemens over Y total, and we found Y total is 769.25 microsiemens. This is equal negative 49.45 degrees. Okay, this is the angle which you're supposed to write next to Y total. Someone is going to say, but I'm dealing with the RL circuit, right? And I'm supposed to get positive angle. Positive angle you are going to write next to the total impedance. Next to total admittance, you're supposed to write negative angle. So I have Y total is equal 769.23 microsiemens and angle of negative 49.45 degrees. Okay, so this is the total admittance of my circuit. Next, we're supposed to find the inductance in our circuit. In order to do so, we're supposed to write the formula for the inductive reactance. X of L is equal 2 pi FL. But please notice that we do not have given frequency, but we have omega, so we can say that X of L is equal omega L. In order to find L, I'm supposed to solve this formula for L. So L is equal X of L over omega. But someone is going to say, we do not have X of L. Yes, we don't have X of L, but we have BL. Don't forget that X of L is equal to the reciprocal of BL. So I can say that this is nothing else, just 1 over BL over omega. Because I have a fraction in the numerator, I can also create fraction in the denominator. Okay, I'm doing this for some of you who still have difficulties with algebra. So I have 1 over BL. Anytime you divide fractions, you're supposed to convert division to multiplication and flip the second fraction upside down. So I have 1 over omega. So I'm going to have 1 over BL times omega. Don't forget about the parentheses if you are going to use the calculator. So this is equal 1 divided by BL is equal 584.56 microsiemens times omega, which is equal 2 times 10 to the third radians per second. This is equal, I'm going to write over here, L is equal 800 55.34 millihenries. So this is the inductance in my parallel circuit. Now we are ready to find the resistance in the series equivalent circuit. In order to do so, we're supposed to find Z total. But we have to realize that we have given Z total, but we didn't find the angle which is next to Z total. We found the angle which is next to Y total. Of course, someone is going to say the angle next to Z total is nothing else, just the same angle, right, which we have next to Y total, but with opposite sign, okay? It's okay, but let's practice the formula that Z total is equal to 1 over Y total. Next, you're supposed to switch your calculators to rectangular mode, right? I want to get the answer in rectangular form. So I have 1 over Y total we found is equal 769.23 microsiemens, and I have angle negative 49.45 degrees. So I have Z total is equal 845.14 ohms plus J 987.79 ohms, where the real part of my answer is Rs and imaginary part of my answer is nothing else, just X of Ls. Okay, so I found Rs. Next, we're supposed to find voltage which will occur across the inductor in the series equivalent circuit. So let me draw the series equivalent circuit. So I have Rs and I have inductance, Ls. I have to find voltage across this inductor. Please notice that this is equivalent circuit to my parallel one, so the total current in this circuit is going to be equal to the current total current in the parallel circuit. So in order to find VLS, I'm going to use the total current first. I total is equal voltage source over Z total. But as we said before, we don't have Z total, Z total with angle. So I'm going to write voltage source over 1 times 1 over Z total, where 1 over Z total is Y total. That's why I'm going to write voltage source times Y total. Someone is going to ask why you complicate so much. I want you to learn different techniques to solve currents, voltages, and impedances, admittances. That's why I use different ways to solve these problems. So I have voltage source is equal 45 volts times Y total, which is equal 769.23 microsiemens, and angle of negative 49.45 degrees. This is equal, I total is equal 34.61 milliamps and angle of negative 49.45 degrees. So this is the current which will go through this circuit. This is my I total, and this is also the same current which will go through this circuit. But please notice that in this case, this current is going to go through the resistor and inductor. So if you want to find VLS, you're supposed to simply multiply total current by X of Ls. So if I total times X LS, which is equal 34.61 milliamps and angle of negative 49.45 degrees times X of Ls 987.79 ohms and angle of 90 degrees. This is equal 34.18 volts and angle of 40.55 degrees. Okay, so this is the voltage across the inductor in my series equivalent circuit. Next, I'm supposed to find the reactive power QLS. Okay, so write the formula first. QLS is equal I total square times X of Ls. Okay, we are talking about the reactive power, right, in this circuit. So I have I total, which is equal 34.61 milliamps raised to the second power times X of Ls, which is equal 987.79 ohms. This is equal 1.18 volt amp reactive. Please notice that before we were calculating QL for parallel circuit. We obtained the value (1.18 VAR). We found the QLS, means the reactive power for this inductor, and we got exactly the same value, right? So it means that we solved the problem correctly.